Hello physics, here we are. This is chapter 9, homework number 5, and this is problem number 4. So let's see what we've got. We've got a space heater. We're going to forget to turn it off and it's going to run all night, and we're going to need to figure out how much energy it uses, how much that's going to cost, how much that amount of energy could power a 60-watt light bulb, an old-fashioned incandescent kind, and then how long that amount of energy could power a 10-watt LED bulb, the newer, more efficient kind. So let's do all of our step has at once. Oop. Sorry, I had the wrong thing. Step part A. How much energy does it use if you forget to turn it off all night? We're looking for energy. Really, what we're using, this is a power problem. We're looking for work. So for A, we're looking for work is equal to question mark joules. So remember, work and energy have the same units. Even though the wording says energy, we're looking for work. B, how much does this cost? It may sound weird, but what we actually want is we want to know that amount of work, not in units of joules, but in units of money. So work is question mark dollars. It's a little weird, but that is honestly the best way of thinking of these things. Part C, if we had that amount of energy, how long could it power a 60-watt light bulb? So we're looking for a time. Time is equal to question mark seconds. And then part D, how long, how much time could that amount of power, could that amount of energy power a 10-watt light bulb? So for these problems, we don't have to do sketches or anything like that. These we just jump right into the math. So let's see. Part A, how much energy does this use? Let's see. We know 1,500 watts. 1,500 watts is the power of the space heater. That's the rate at which the space heater is going to use energy. And we know the time. Unfortunately, we have the time in the wrong units. But we'll deal with that with our field goal post. So the formula you want to use, the way I would recommend doing this is just look at the footer of the page and copy the formula you're going to use. So the formula we're going to use is power equals work over time. We're going to rearrange that a little bit because we're solving for work. That's going to give us work is equal to power times time. So we know the power. The power is 1,500 watts. And the time is 8 hours. So one thing that might be helpful, you don't absolutely have to do this, but let's rewrite this, and instead of writing 1,500 watts, so work is equal to 1,500, sorry, 1,500. A watt is actually equal to a joule divided by a second. So I just turned that W for watt right here into a joule per second times 8 hours. And now to the field goal post. The problem here is my time is in hours, and I don't want that. I want my time in seconds so I can get it to cancel out with the per seconds in the 1,500 joules per second. So I need field goal post. So what's my first field goal post going to look like? My time is already in units of hours. So I have hours on the top. I want to get out of hours. That means I need hours on the bottom. One thing I know about hours is that 1 hour is the same thing as 60 minutes. So please write 60 min, not 60 m, because m typically means meters. So 60 min over 1 hour. And remember, when you're doing field goal post, the thing on the top has to be equal to the thing on the bottom, just in different units. 60 minutes is 1 hour. So 60 minutes divided by 1 hour, that's a good field goal post. So I have hour on the top over here. That's going to go away. I have hour on the bottom over here. So those go away. And now my next field goal post, I want to get out of minutes and into seconds. So Minutes is on the top in the last field goal post. I want to get rid of that. So I'm putting minutes on the bottom, and I want to get into seconds. The thing I know about minutes and seconds is that 1 minute is the same thing as 60 seconds. So now minutes up here cancels with minutes down here. And then the last thing we have is all the way back in the beginning, I had 1,500 joules per second. I had seconds on the bottom. And in my last field goal post, I have seconds on the top. So seconds on the bottom, way back here, is going to cancel with seconds on the top. And the only unit I have left now is joules. So if I do all of this, I'm going to end up with some number in joules, which is what I want. So in the calculator, 1,500 times 8 times 60 times 60, and then divided by 1 and divided by 1. Obviously, dividing by 1 is kind of optional. You don't actually have to hit those buttons. If we do all this, we're going to get a very big number. We're going to get 432,000,000, and then that's in joules. So let's put the commas in so this is a little bit easier to read. Comma there, 3 more spaces, comma here. So we have 43,200,000 joules, which is another way of saying 43.2 million joules. And another way you can write this, you don't have to write it this way. In physics, too, you'll have to write things this way sometimes. You could call this 43.2 capital MJ. The capital M in this case means mega. It means million. So there's my answer for part A. I solved for the right thing. I have the right units. It is in joules. So step, I'm happy with that. Part B. How much does this cost at 11 kilowatts per hour? Okay. So I don't actually need a formula for this. This is really just 100% a field goal post problem. What I've got to do is start with the amount of work we have. Work is equal to 43,200,000 joules. And I need to do a bunch of field goal posts until I have converted that amount of work into money. Now, one thing you can do, maybe not absolutely necessary, but I find it helpful, is I'm going to get rid of that joule at the end. And I know that 1 watt is a joule per second. That also means that 1 joule is a watt times a second. So by doing this, this might make my field goal post make a little bit more sense. Because ultimately, I want to turn this from something in units of watt seconds into something that is in units of kilowatt hours, and then I want one more field goal post to get me out of kilowatt hours and into money. So this is a good place to start. So to get into kilowatt hours, first thing is let's do field goal posts that change watts into kilowatts. So my first field goal post, I already have watts in the top, so I'm going to want watts in the bottom, kilowatts in the top. And the thing about watts and kilowatts, because of the beauty of the metric system, 1,000 watts is 1 kilowatt. So by doing this, I would get rid of the watts. I would have my answer in now kilowatt seconds. Now I need to get out of seconds on the top, and ultimately I need to get into hours. So first, let's get the time into minutes. So seconds were on the top, which means I need seconds on the bottom. I need minutes on the top. And I know that 60 seconds is the same as 1 minute. So that will get me out of seconds, put me into minutes. And then I need to get out of minutes and into hours. So minutes on the bottom, H on the top. And I know that 60 minutes is the same as 1 hour. So if I look at the units I have left, at this point I have kilowatts and hours on the top, so I'm in units of kilowatt hours. So this is good. The last field goal post we need is the one that gets me out of kilowatt hours and into money, which always seems weird, but that is what we're doing. So the way we're going to do that, we're in kilowatt hours on the top, so we're going to want kilowatt hours on the bottom, and we know that 1 kilowatt hour costs 11 cents, so $0.11. So now I've got a lot of work to do in the calculator. but take it part by part. It won't be that bad. So start with 43,200,000, multiply by 1, by 1, by 1, and then by 0.11 for the 11 cents, and then you divide by 1,000, and then you divide by 60, and then you divide by 60, and then you divide by 1. And if you do all of that, you're going to get $1.32. And does that answer make sense? Yeah, it seems to make sense. That is a reasonable amount of money. One thing I would like to point out at this point is if you set your field goal posts up, you're going to get a reasonable, if you set them up correctly, you're going to get a reasonable amount of money. If you do it incorrectly, it's going to be weird. If I flipped all of these, if in this first one I had 1,000 on the top, 1 on the bottom, 60 on the top, 60 on the bottom, this 60 on the top, and then whatever with the last one, I'm going to end up with some absurdly large amount of money. It might be trillions of dollars. It might be even more than that. So when I get to the end and I do my step, does my answer make sense? You have to think, if you leave your space heater on all night, that will cost you some reasonable amount of money, but it won't cost you trillions of dollars. That's not how the electric bill works. So hopefully that makes sense. And time is running a little bit long here, so I think what I'm going to do is stop this video now and do a part 2 for this video, where we handle part C and D of this problem.